So in this video, we're going to look at one more application of the fundamental theorem of calculus and then some of the properties that deal with it. So just remember the fundamental theorem of calculus says that if I have the integral from a to b of f prime of x or f of x, whichever one, dx, then that would equal the original function evaluated at b first and then minus f of a. And you can use that notation, or you can use like f of x means the derivative of capital F of x and use that notation. They're pretty much interchangeable. So if they say given f prime of x equals negative 5x plus 10, compute f of 4 minus f of 2, what we're really using is this idea. So we know that f of 4 minus f of 2 would be, using that fundamental theorem, the integral from 2 to 4. Okay, so b is my upper bound, a is my lower bound of this derivative. And we're going to take that integral with respect to x. And then to find the value, we would actually integrate and use the fundamental theorem. So the integral of negative 5x is negative 5x squared over 2. Plus the integral of 10 is 10x. When we're doing a definite integral, we don't need the plus c since it will cancel. So I'm not going to put it. I just put a line and then the bounds. Okay, and then I plug in my upper bound to all of the terms. And then subtract, I plug in the lower bound, all the terms. Again, make sure you have parentheses or change the sign because you're subtracting both of these terms. And then from there, it's pretty much just simplifying. So this should give us negative 40 plus 40 minus negative 10 plus 20. So that gives me 0 minus 10. And so we get negative 10. And that means that, I mean, you could graph it to see as well, but if you have negative 5x plus 10, I'm just graphing that line. We said from 2 to 4. So it would look like this line. This would be my 2, 5. And we would be finding the area. We're going to say this is 2. Between the x-axis and our curve. So we're finding this area. And again, because it's below the x-axis, it makes sense that it's negative. You could also find this area graphically in order to get the area. So the height, this goes to 10, so this would be 10, and the width is 2. So if you found the area of that triangle, it'd be 1/2, 2 times 10. And because it's below the x-axis, it's negative, which would give me negative 10. So that's an application of the fundamental theorem of calculus.